Hello everyone, so now we are going to do the next topic, BGP Peer Group. So what is the meaning of this one? In simple, if you know Active Directory, what we are doing in the Active Directory, we will add all the user and then we will apply the policy on that group. We will create one group, we will add all the user in the group and then we will apply the policy in the Active Directory. If you work before in the system administration, you will know this Active Directory. Or imagine if I want to run some policy, I will make one group, I will add all the neighbor in that group and then I will apply the policy. So it will work on all the neighbor. Same thing we will do here. So what we are doing here, we are creating one group. What are the advantage we are going to get by using this BGP peer group? What advantage we are going to get? Example, if you see here, I have this 3 neighbor. Okay, I am the one and I have this 3 neighbor. Imagine I am making the neighborship from this loopback 0 to this loopback 2, 3, 4. So I need to write here same command. I need to write this multi-hop 2 for this, multi-hop 2 for this, multi-hop 2 for this. And again I need to write the update source loopback 1, update source loopback 1, like that command I need to write. Let me show you here. This one. If I did not use the peer group, what I need to write? This command I used to make the neighbor 2.2, this command I used to make the neighbor, this command I used to make the neighbor, and this command I used to advertise our network. After that I use neighbor 2.2.2 update source loopback 1. Again same thing, I am saying another neighbor update source loopback 1. Again I am saying update source loopback 1. And then again I am saying EBGP multi-hop 2. EBGP multi-hop 2, EBGP multi-hop 2. Now I have only 3 router, so I am writing for 3. If you see here, how many router I have? Only 3. Imagine if I have 200 router. Imagine if I have 200 router, then what I will do? I will write this 200 time. What I will write 200 time? This one. Update source loopback 1, update source loopback 1, update source loopback 1. I will write for 200 times. And same thing I will write this EBGP multi-hop 2, EBGP multi-hop 2 for all 200 neighbors. So I need to write 200 times this command, 200 times this command. And also we will have the issue, CPU is going to execute separately. For this command he will execute separately, for this command he will execute separately, for this command they will execute separately. So our CPU will consume more. Router is going to consume CPU more. To overcome these types of issue, what we will do? We will create one group. Okay, I am creating one group and then we will add this neighbor in that group. I will add all these 3 neighbor in that group. Then I will run the command one time, update source loopback 1. I will apply this in the group 1. Same thing in that group we will say EBGP multi-hop 2. So what we done here? We created one group. This is a group name. We can give any name here. I am writing GP1, group 1. You can write here ABC or anything. Okay. And then I am adding all the neighbor in that group. How we can add? We can write neighbor and give the neighbor IP. And then we can write the peer group and the group number, whatever group. So this way we will add the neighbor. So if you have 200 neighbor, first time you will create, they will group. And you will add all that neighbor in that group, and after that you will just apply the policy, whatever you want to apply the comments in that group. So it will affect all the member whoever in that group, and CPU will run only this one time, so they will save the CPU also. Okay, same thing this one also. So this is the advantage by using the peer group. If you see here, I wrote same theory here what we discussed just now. When you configure BGP on the router, it is possible that some of the BGP neighbors share the exact same configuration. Okay, with this we can type the exactly same again and again same configuration. And issue what we will have, our CPU is running separately. Okay, to simplify this one, we can create the group and add all the neighbor in that group, and we can apply that command or configuration to that group. With that one we will reduce the comments, and also our CPU will consume less, which required less CPU resources than preparing them for each neighbor separately. So when we are running for separately, it will take a lot of CPU, but now we created group and he will execute the group. So all neighbor will have the same command. So this way we can save the CPU also. So what we are saying in simple, just we are saying we are creating one group and we are adding all the neighbor in that group, and then we are applying the configuration to that group. So with that one, CPU will not consume more because CPU is executing for that group, not for the individual neighbor. If it is executing for individual neighbor, if you have 200 neighbor, then you need to run for 200 time. Okay. So to overcome these types of issue, we use the peer group. So now let's do this lab. So what I will do here, let me stop this router and we will create the scenario something similar like this. So I will put the lab name will be BGP Peer Group. Let me create the new lab here. I will give here, and yeah, so let me start here. Now how we will draw, same scenario we will use. We will take one router here, 3 router here. Okay, so I will take the one router here and then we will take the 3 router here. So I will make one here, R2 here, R3 here and R4 here. Okay, so what we will do here, we will connect the same thing we will do as we done before. Configuration will be same only. Let me connect here. I will take fast Ethernet 0x0 will go to fast Ethernet 0x0. I will enable the ports here and then I will use the fast Ethernet 0x1 here to fast Ethernet 0x1 here. Let me move this up like this, and then I will connect one more cable from here to here. This is the fast Ethernet 2x0 to 2x0. You can connect any port anywhere, no issue. For simplicity, I am using the same port for the opposite side. Okay, so this is our topology. Let me start the router, so it will boot up and we can define our IP schema. Here I will give the loopback 0 or loopback 1, whatever we want we can use. I will write loopback 0 here, or let me take 1 as we are saying the router number, and I will give the IP 1.1.1/24 as we used just now, same thing. So this is our loopback we will have here, and I will make the duplicate. We will have here loopback. So this is a router 2, so I will say this will be loopback 2, and I will write here this will be 2.2.2. Okay, so now what I will do, I will make duplicate. I will take this here, this will be loopback 3, and we will write the IP will be 3.3.3. so I will go here 3.3.3.3, and then we will make this duplicate, and I will make here this is a loopback 4. Even if you want to use same loopback, you can use same loopback. IP should be different because they will exchange the route. Loopback is a local significant, so we can use same number also, no issue for the loopback number. But anyhow, for simplicity purpose, I will use the loopback different, and AS also we need to use. So what I will do here, AS1 autonomous system 1 here in the router 1, here I will use 2, and then what we will do, I will make duplicate, this will be 3. This is little big lab, maybe it will take 40 minutes or maybe 1 hour, but if we do, we will have a good concept. Okay, so now we have the 4 AS. An IP schema what we are going to use here, I will use 192.168.12.0/24 between from here to here. Okay, and the other one will be 1.3. I will use the router number 3, 1 from here and 3 from here. So we will use that side this IP, and this side we will use 14 because R1 and router 4 we have here, so I will write 4. So 14.1 here, 14.4 will be here. So this IP we are going to use. Okay, so let's do the basic configuration. So I will write here And title, what we will give here, BGP Peer Group. So let me write the title here. I will write BGP Peer Group Lab. Okay, and I will copy the same thing so we can put in our notepad also. So this is our notepad. I can save also. Let me save this one, BGP. So let me remove this colon. Okay, so now we need to write first of all R1 configuration. So same thing as we do, basic configuration will remain same, R1. Okay, and then we need to look for the interface fast Ethernet 0x0. What will be the IP address 192.168.1.12.1 255.255.255.0. then we write no shut here. Second interface fast Ethernet 1x0, and then IP address what we have here 192.168.13.1 255.255.255.255.0, and we write here no shut, and then we write interface fast Ethernet F2x0, and then we write IP address 192.168.14.1 255.255.255.0, and we write no shut here. Okay, so these three and one more, that is the interface loopback 1, IP address 1.1.1.1 255.255.255.0. Why I wrote 3 times 255? Because we are using /24. Okay, what I done, just I assign the IP address to the R1. This is a basic configuration, just we assign the IP address. Now we need to do for R2 R3, so I will just divide this notepad and then let me copy paste and we will modify as per our requirement. Okay, so I will go here, I will paste here, and if you see, this will be R2, this will be R2, and this is a R2 fast Ethernet 0x0 12.1. so I will write this as a 12.2 because this is a R2. So this IP is okay, and then we will have the loopback. So I will copy this configuration from there, I will paste here, and here we have the loopback 2. Okay, loopback 2, and then here we will write 2.2.2.2. okay, so this R2 IP address configuration finish. Now we will do for R3. So R3 I will copy and paste from here, and this will be 3. This one I am doing, and here also 3, and what we have here 13. So I will make this as a 13.3. okay, router number we are using 13.3 this side, and loopback will be 3, and this IP will be 3.3.3.3. okay, this one finish. Later we will do BGP configuration also. Now I am doing only for the IP address. So this one we will copy and paste here, and we have here 4, and we have here 4, and this will be 14.4, and this will be 4, and here this should be 4. Let me write 4.4.4.4. okay, I assign IP correctly, right? Check if I miss anything. This one, this interface, this interface, this interface, F0x0, F1x0, F2x0 loopback, and this 14. okay, and for R2 this is R2 12.2 0x0, and this is 2, and this is R3 0x0. No, if you see here we done mistake here. This R3 is having F1x0. so where is R3? This R3 F1x0. so this should be 1. okay, this one I am saying. So R3 is this one, this IP. okay, and R4 also same thing, F2x0. so I will change this as a 2. This is F2x0, and this is the IP 192.168.14.4. okay, so this is good, everything is good. Now this IP is okay. Let me take the console of the router, we can paste the IP. So let me cancel the old console, this is a new console. okay, so let me take the console of the router 2, router 3, router 4, all console, router 2. Let me take the console of the 3 also, and console of the 4 also. Okay, now just I can paste the configuration also. This is just IP address, so this is a R1. I will paste here. Everything is good, no issue, right? Everything is good. Let me copy for the R2. This is the R2. I will go in the R2. I will paste in R2. So this is good also. Now I will go for R3. I will paste in the R3. This is R3 is okay. Now we will go for R4. We will have the R4. So this is R4 is also okay. So now just we assign the IP address. Okay. And now what we need to do, if you remember, we are making the neighborship from the loopback. So whenever we are making the loopback, we should remember we need to do the static route or any routing protocol. So they should have the connectivity. If you want, example, I am here in the R1. I am here in the R1. If I want to ping 2.2.2, I cannot. Let me do here ping 2.2.2.2. I cannot because we don't have the reachability. So I need to define the static route. If you remember, just now in our previous lab we done the static route. Why we done? Because we need to have the reachability. Then only we can do the BGP. When we want to run the BGP, we should have the reachability. Then only we can do the BGP configuration. So what I will do here, I will define the static route. IP route 2.2.2.0 255.255.255.0 this IP 192.168.12.2. okay, what I am saying, R1, if anyone want to go to 2.2.2 network, forward to 12.2, this one. Okay, this is clear, right? I need to write 3 times. Why I need to write 3 times? One here, second one here, third one here. So we need to have 3 route, but we will change here. This should be 3.3.3 and here this should be 13.2, here 13.2, and here you will have 4.4.4 and here will be 14.2. So what we are doing, we are creating the static route, saying that if anyone want to go to 2.2.2, forward the traffic to this IP. Same thing we need to do here also, from here to here. If anyone want to go from 2.2.2 to 1.1.1, they need to forward the traffic to this IP, 12.1. Okay, we need to write that one also, the opposite way. So what I will do, I will go in the R1, I will say here IP route 1.1.1.0 255.255.255.0 then 192.168.12.1. okay, in R1. I need to do same in the, this is for R2. I need to do same thing in R3 also. So I will do here in R3, but I will write this will be same, but this will be 13.1. okay, and in R4 also we will have same thing, but will be 14.1. what we are saying, R4, if anyone want to go to 1.1.1, forward the traffic to 14.1. so now I will paste this route in that one. Okay, so I will put this default route. So I will go here in the R1, I will go in the global configuration mode, I will paste this default route. This is good. Then I will copy from the R1 and R2 and I will paste in the R2. I will paste here. Now I need to go to R3 and I need to paste the R3 one. So let me go to R3. I will copy from R3 and I will paste in the R3 this one. Now I need to go to R4. I will copy this. I will paste in the R4. So this is the R4. I will exit this. I will paste here. Okay. So this one first thing is finished. Now we can start the BGP configuration. Okay, what we can do the BGP configuration. So if you remember, if we are not using the group, then how we will do the BGP configuration? Let me show you. We will let me write here. Okay, without group I will show you. So what I will write here? I will write here router BGP1. First command we will write this one. Then we need to define the neighbor. So I will write neighbor. And who is my neighbor? I am here in the R1. This is my neighbor 2.2.2. So I will write 2.2.2.2 and then remote dash AS. What is the AS? 2, because this is the 2. And same thing I need to do for 3 and 4. So I will copy this. I will paste here. And this one I will change this as a 3.3.3.3, and here I will change this one as a 3. Okay, because I am saying, let me show you here this one. I am saying neighbor 3.3.3 remote AS 3. Same thing I will do 4.4.4 and then remote AS will be 4. Okay, 2, 3, 4. So I am saying this is my neighbor and neighbor AS is 2. This is my neighbor 3.3.3 and his AS is 3. And this is my neighbor, that is 4.4.4.4. And what I can say, this is neighbor AS is 4. And I want to advertise my network. So I will write here network. Then I will write 1.1.1.0. And I will write the mask 255.255.255.0. Okay, this way I advertise our own network. R1 is advertising his own network, that is 1.1.1.0 mask 255.255.255.0. After that, what we need to write? If you remember, we need to write neighbor. What we need to write? What is a neighbor? 2.2.2.2, and we need to write update dash source loopback. What is the loopback? Our loopback 1. So I am saying to my neighbor 2.2.2, can you update source will be my loopback, make the neighbor shift from my loopback 1. So same thing I need to say to this one and this one also. So I will copy this configuration. How many times I can copy? 3 times. Okay, so now here I will tell to 3.3.3. So I will write 3.3.3. This remains same because my source is only, my loopback is only 1. So I want to update that one only. So I will tell to 4.4.4 also, can you please update source loopback will be 1. Okay, now after that what we need to do? We need to increase our TTL value also. Just now we look, if we are making the neighbor shift from the loopback, we need to use increase the TTL value. Okay, so how we will increase the TTL value? We will say neighbor 2.2.2.2, then eBGP multi-hop 2. Okay, and we need to do the same thing for all the neighbor. We have 3 neighbor, right? 2.2.2 and then 3.3.3, 3.3.3, and then we have the 4.4.4. Okay, so this what I done, I wrote this 1 time, this 3 time, and this one 3 time. If I create group, I will write this only 1 time. This is without neighborship, without group, without peer group. Okay, let's do the R2 configuration. So R2, what will be the R2 configuration? In the R2, what I will write? R2 simple, only we have 1 neighbor, so directly we can write router BGP1, BGP what? BGP2. R2 is having AS as a 2, this one. So I will write router BGP2, then we can write neighbor. Let me copy from here so we can change the configuration. So here, so I will say neighbor, I am in the 2, I am saying to 1. So I will write neighbor 1.1.1.1 and remote AS for R1 AS is 1. AS is 1 here. Okay, so what I am saying, router BGP2. I am router BGP2 and my neighbor is 1.1.1 and his AS is 1. This is first thing we finish. And then what we need to do? We need to advertise our network. So we can write network command and we can advertise our network also. So I will write here network. And what is our network? 2.2.2.0 and mask 255.255.255.0. And now we need to write this two command. Which command? This one, loopback update. And then we need to write also this multi-hop also. Okay, so what we need to do here? We need to write neighbor. Our neighbor is 1.1.1. So we'll say neighbor 1.1.1.1 updates loop source loop update source loopback. Our loopback is 2, so we need to write 2. Our loopback we need to give. After that we will say neighbor 1.1.1 1.1.1.1 eBGP multi-hop 2. Okay, so what we are saying? First we are saying neighbor update the loopback as a 2 and then give the eBGP as this one. Okay, so this is a configuration for the R2. I will copy the same configuration. I will paste in the R3 and we will make the changes as per our this one. So this R3 is having AS as 3, so I will make this as a 3 and my neighbor is this one only and my neighbor AS is 1 only and our network, this network is 3, so I will write here 3.3.3 3.3.3. okay, and this will remain same and here only loopback will change. Our loopback is loopback 3 and this remains same. Okay, this is a R3 configuration. I will copy, I will go here, I will paste in the R4. If you see, this will be remain 4 and neighbor will be same. This is my neighbor 1.1.1 and remote AS will be same and our network will be 4. So I will write here 4.4.4 and then this both are our neighbor but our loopback is 4. All remaining configuration remains same. Okay, so now we can paste this one. You need to remember this 2 command is extra. Why we are using this command? Because we are making the neighbor shift from the loopback and this command to increase the TTL value. Okay, so now I can paste this configuration in the R1. This is the R1 configuration from here to here. But if I don't want to use this one, then I can create the group and I can do in the group also. So before pasting this R1, let me paste the R2. So this is a R2 configuration. I will copy this whole thing. I will go in the R2 CLI. This is the R2 CLI. I will paste here. If you see no error, everything is good in the R2. So now I will copy it to R3. This is a R3 configuration. I will go in the R3. I will paste here. Everything is good, no error, nothing. Now we will go for the R4. This is my R4. I will copy this and we will go in the R4 and we will paste. Something wrong here. Let me check in the R4. Yeah, everything is good here, right? Only R4 is having some issue. Here nothing, here nothing. So let me check in R4 we have neighbor. So I think I wrote neighbor spelling mistake. NEIG.
Router BGP4 sir.
Router BGP. Where you are saying here? I forget
You need to copy router BGP4 sir.
Ah yes, I forget this one. Let me copy. Yeah, thank you. So I will copy, then we will go here and we will paste here. Okay, so now this will be okay and now we can put this big configuration in the R1 but now we will learn how we can do the group. So we can paste this. Even if we paste this, they will have the neighborship, but now we will use the group. So I will write here somewhere here without, like this I can write without peer group, this configuration, and the other one I will write here. This one is a with peer group. So now the group configuration we will do. The configuration will be simple only. What we will do, we will write the whole thing. Just for the neighborship we will do that one. So let me copy and paste. This will be remain from here to here. This will be same. We need to advertise, so I will copy this whole thing. I will paste here, and after that what we will do, we need to create the one group here. Okay, so what I will do, I will create the group here. So we need to write here neighbor, and then I need to write give the group name GP1 I am giving. I can give anything, whatever the group name we need, we can use that one. After that we need to write peer group, and now we need to add the neighbor to the group. How we will add the neighbor? I will just copy from here to here. This is my one neighbor and this is my another neighbor. I will put here, and this is my another neighbor. I will put here, and we need to write neighbor and give the neighbor ID, and then we will write peer dash group and group name GP1 we are using. So this one we need to put to all the neighbors. So here I will write this, here I will write this. Okay, so what we done here, with this command we created the group. We need to write neighbor group, whatever name you want to give, ABC, and the peer group, and then we will add. I have three neighbor, 1 2 3, these three neighbors. So I will add neighbor 2.2.2 peer group the G1. So in the group 1 I am adding this three neighbor, and now what I can do, I can apply the command to the one group only. So I will write here neighbor, and then neighbor which group, GP1 group, and the command we have update source. What we have, update source loop back 1, and same thing we will do neighbor GP1, and what EBGP what we told, multi-hop 2. So just I apply this command to this group GP1 group, and this command also I am applying to GP1 group, and in GP1 group what we done, we add this neighbor, so it will apply to this all. So now I can paste this one or I can paste this one, both are same only, but here we write the separately. If you see, we write this one time for this, one time for this, one time for this, but here I created group, this is a group, and in that group we add all the neighbor, then we apply this command directly on the group. So with this one configuration also reduce, and also we will have the, what we can say, CPU also not consume the RAM. So I will copy this one, I will paste here. We will go this in the R1 and we will paste in the R1. So now I will paste. Again we have some issue here. Let me check what is the issue. I put spelling mistake. You should not there here. Let me correct. So where I put here, let me remove this U and U. Now I will put this two command. What happened? Let me copy and then paste here. Okay, so now I pasted. So now we will have that one. Now we can check. After some time neighborship will come up and we can check that one. So here we need to wait. BGP is a slow protocol, show IP BGP. So we will get, I am here in the 4 only, show IP BGP, still we did not get show IP BGP summary. If we see, it is struck in the ideal only, so we need to check. We will have some issue. Now this go up. Okay, it will take some time. After that it will up. So this R1 is up. If you see here also R2 is up. Now we will see R3 is still not, and R4 is still not. So show IP BGP. In R4 it is in the ideal state. In R3, let me check what is the status in the R3. Show IP BGP summary is still ideal. In R2, Let me check. Show IP BGP summary. Okay, here no problem for R2. R2 is okay, but R3, R4 is still having some issue. Maybe we done some misconfiguration. Let me check what we have for R2 and R3. So R3 and R4 is having the issue. So we need to check what we done here. We have the IP, we have the loopback, and we created the default route. Okay, 13.1, and then here neighbor 1.1.1 remote AS and neighbor network. This command we advertise, and update source loopback 3 and multi-hop this. So this is correct only. We should have here they have, but here still the issue, something wrong. Let's check the interface. Show IP interface brief. All interface is up or not. So if you see, we are using this interface, this is up, and we are using this interface, this is also up. And if we check here also, show IP interface brief. So this interface we are using, it is up, and this interface, let me write clear IP. Sometime we will have clear IP BGP star. Okay, and here also I will write clear IP BGP star. Still they did not find the neighborship here. We have default route or no here? Let me check. Show IP route. If we don't have default route, we have the default route to go to that one. And if we check here, show IP route, we have the default route. We have the default route also. In R1, show IP route, we have the default route to go to R3 and R4. Let me write here. Show IP route static route, not the default, static I am saying. So this one, for 2 I can go, 3 I can go, 4 I can go. This is okay, but here something wrong in the R3. So because neighborship not formed here, we can check. Now it is active. Before it is in ideal. So let's see what we have here. It is in ideal, but this one is inactive. I can ping here 1.1.1. So let's see, maybe something we miss here in the configuration. We have issue the R3. So R3, let me cross check R3 configuration. This is a R3. Here what we have, the interface F1/0, 13.3 this side, and this is 255 and this is a loopback 3.3.3, and we have the default route IP route 1.1.1.0 255, and here 13.1. okay, and BGP 3 we are saying neighbor 1.1.1 remote AS1. okay, this is good. And our network 3.3.0 mask 3 times 255, we are saying neighbor 1.1.1 update source loopback 3, and we write neighbor 1.1.1 eBGP multi-hop 2. So this is correct only. Maybe in the group here we done something wrong here in the group. Let's see here. This is the 2.2.2. This is one neighbor. This is another neighbor. This is another neighbor. And this is our own network command. We are advertising with the network. And then this is the neighbor GP1 peer group, and neighbor 2.2.2 peer group GP1, neighbor 3.3.3 peer group GP1, and this is also 4.4.4 GP1.
I think the static route on
R1. Let me check. I think static route we have here. If you see, R1 is going towards here for 2.2.2, for 3.3.3 and 4.4.4.
Is it 13.3 or 13.2?
This one 13, yes, maybe something, yes, yeah, good observation. Yes, this should be, we write something here, issue, let me correct here, 13.3, not the 13.2. This should be 13.3, here should be 14.4, not 14.2 also. Let me check here, this is okay. Let's go for the R2. If we see this IP, R2 is okay, R3. So this one, if you see 13.3. So what issue we done here in the static root, somewhere we, this one, this should be 3 and this should be 4. Okay. In the R1 we put the wrong static root, that's why we have the issue. So what I will do, in R1 I will go in the global configuration mode, I will write here, or let me do show run, I can copy the static root. Thank you, yeah, good observation, this one. So what I will do, I will copy the static root, this two root I need to remove, this one. So I will do this, I will write no and then we will paste this, and then we will copy this also and I will write no here and I will paste here. So these two roots remove. Now I will put the correct root. So the correct root will be these two. Now I will paste, now it will come up. Okay, so after some time this will be okay. See, the states, if you see, before ideal open connect, now it is up. Now if we see here also, it is up now, and we are getting the root also. So what I will do, I will write here show IP BGP. So if we see here, we have the, we are in the R3 and we are getting this one. Okay, and if we see here R4, we can write here show IP BGP, and if we see here what we are getting, this one, our next hop will be 1.1.1, and here this is 0. As we told, if we are getting from the same router, next hop will be same, so we will have this number. If we don't have the next hop is will be the different router, that's why this become as a 0. And this is will be the AS, we have AS1, AS2, and here if we see AS1, AS3, AS is nothing but how many AS it is away from how many AS. So if you see this route, I am saying example this 2.2.2. So this 2.2.2, if we want to go, we have AS1, first I need to go to AS1, then from I need to go to AS2. So I am here, example, let me show, I am standing here in the R4. If I want to go to this 2.2.2, this network, so how many AS away from me? So I am here in the AS4. So first I need to go to AS1, this one, then from there I need to go to AS, this AS, which AS? AS2. So this way it will show you, first you need to go to AS1, then again you need to go to AS2. So you have 2 AS here. And if you want to go to 3. Network, how many AS away from you? Again 2 AS. This is 1 AS and this is another AS. Total is 2. It is written AS number as 1, AS number as 3, but if you count, this is 1 and this is 1. So 2 AS away from you. So now if you see, I want to go to 3.3.3. So you will go from here to 1, then from 1 to 3. So this is 1 AS, AS1, and this is AS3. So how many AS away from you? This is 2 AS away from you. Because in the attributes we are going to discuss this. That's why just I am giving you overview. This is the AS number. How many AS away from us? So this is a 2, 1 and 3. This is 2 AS away from us. This is 2 AS away from us. This is only 1 AS away from us. And here this is our own route. So that's why it is not showing any AS. Okay. So now we have this, and if we check here also, we will have show IP BGP. So we will have here, this one is our own route, that's why we have 0.0.0 as a next hop, and when next hop will be our router only, then we will have wait will be 3278. And this one, if we want to go here, this is the next hop, so we need to send the traffic to this IP. That's why we don't have any number here. If it is not next hop is not 00, then you will have the number as 0. And here also if we want to go to 3 network, then next hop will be this, and here wait will be 0. And here if you see this one, how many AS, this is AS2, AS3, AS4. If we want to go to 4, we have the AS number 4. Here is AS3, AS2. We have only one AS. If you see, this is written as a 2, but only one AS away. This is AS number. Directly it is showing you what AS they are using. If you are getting 3 AS in between the route, then you will have here whatever AS, then again another AS, then again another AS, as we have here 1 and 3 it is showing. Same like this, you have only one AS, but that AS number is 4. You have only one AS. If you want to go to 3.3.3 network, you have only one AS. That AS number is 3, this one. If you want to go to 4.4.4 network, then you have only one AS. That is 4. That number is 4. If you have 2, 3 AS, then it will appear like this. You will have AS1, then AS3, then AS4, AS5. If you have lot of router, lot of different AS, then it will show that way. Okay, so what we done here in this one, just we do the configuration by using the group. Why we want to create the group? To save the CPU utilization and also to reduce the configuration. So this configuration is without peer group, and this configuration is with peer group. And here in this labs, what we learn, this lab and just before lab, we learn these two command. These two command. First one is, whenever we are making the neighborship, we need to write update source loopback, and whenever we are having the relation or the neighborship from the loopback, we need to increase the TTL value. This most important thing, these two command. After that, remaining is same, just we created the group and we add in the group. Okay, so now let me stop the recording.